Alright, chemistry students, here we go. First screencast of the year, my first attempt at this for a chemistry class. So, this is a PowerPoint presentation you're going to be going through and watching as I take you through this and walk you through some of the concepts and ideas. Your job is to take notes. Think of the key points. You don't need to write down everything I say. You don't need to write down everything that's on these slides. Pick out key points, things that I emphasize as I go through and talk about matter, properties, and changes. So on this first slide, what is matter? Not what is the matter, what is matter? Definition: anything that has mass and volume, anything that has mass and takes up space. So basically anything that we're going to be working with in this class can be classified as matter. Just got done going through an entire lesson and set of activities looking at classifying matter, breaking it down into its different forms. Pure substances versus mixtures, elements versus compounds, things of that nature. So we understand the different classifications of matter now, hopefully. Now, what kind of changes does matter undergo? There's the two main types that we're going to be looking at: physical and chemical changes. This idea of microscopic versus macroscopic. Microscopic, that's the things that happen at the atomic and molecular level. We can't see what's going on when things are combining, when atoms are combining to form molecules, and when elements become compounds. We see evidence of that, and that's the macroscopic piece. Macroscopic, that's the things that we see. For example, when the sulfur and the copper reacted in the demo from class on block day, we started out with a yellowish powder and a reddish powder and ended up with that dark blue black solid. That's macroscopic. Those are things that we can see. Physical changes. One of the better definitions I've used for this in the past is a change in the size, the shape, or the phase. Here they're calling it state. This is a phase change, something like freezing. Now, the reason it's a physical change is because the properties of that substance, the chemical makeup, does not change. If I take water and I freeze it, and then I take that ice cube and I hit it with a hammer and I break it into smaller pieces, the molecules, the smallest particles of that matter, which consist of 2 atoms of hydrogen and 1 atom of oxygen, do not change, whether it's in its liquid form, its solid form, or even smaller pieces of that solid form. The chemical makeup does not change. If I could take a microscopic picture of it in all 3 of those phases, it would look the same. Chemical changes, that's different. Now all of a sudden, if something undergoes a chemical change, you might start with atoms of one element, and then they all of a sudden combine with atoms of another element, and you have molecules. When this happens, you get substances with different properties, just like when we heated up the copper and the sulfur to make the copper sulfide. We obviously had a different substance there. It had different properties. Color, texture, there was an odor that we noticed. Some of the common signs of chemical change, the things that I like to talk about. If you have a gas produced, and so here they're talking about bubbles forming, a gas that was not there before. Now, we're not talking about evaporation, that's different. When there is a gas that's formed that wasn't there before. If there is a color change, it's a great indicator that a chemical change has occurred. If there is energy involved, if you have to heat something, or if energy gets produced, if all of a sudden there is a temperature change when you mix 2 substances together, that's a great way to indicate that you have a chemical change occurring. Now, the other piece of this, we've talked about chemical and physical changes. To be able to recognize that a chemical or physical change has occurred, you have to be able to identify the properties of the substances. What are their characteristics? What sets them apart from something else? So we're going to look at 2 different types of properties, just like we looked at 2 different types of changes. Physical properties are those that we can determine without changing the identity or the chemical makeup of the substance. Examples: physical properties of sodium metal. Sodium is an element, so it's made up of only one kind of atom. If I take sodium and I'm testing the properties that we have listed here, hardness, color, melting point, and density. To test these, it's a soft metal. You can scratch it with your fingernail. You can cut it with a butter knife. But by doing those things, I am not changing what it's made of. I still have atoms of sodium. When I look at its color, by looking at it, I'm not going to change it into some other type of element. I'm not going to make those atoms combine with something else. When I melt it, and I measure the temperature at which it melts, I am not changing the fact that I still have sodium atoms. Same thing with density. Measuring its mass and measuring its volume and calculating its density does not change the fact that it's still made up of one kind of atom. If you think back to the activity we did and you had the circles and the triangles and the squares, if you could take a little picture of it, they would all still look the same. Nothing changes about the chemical makeup of those particles at the particle level when you are measuring physical properties. Chemical properties, on the other hand, these are things that when you measure them, you have to change the substance. You can't determine whether something's going to react with something else without reacting it. And when you react it, you change its chemical makeup. You're either combining atoms to make a new compound, you're taking a compound and breaking it apart, or you're rearranging the atoms within a molecule. All of these things change the chemical makeup. So I can't test chemical properties without changing the substance, both microscopic and macroscopic. Some examples, the sodium metal that we were talking about earlier is in a group on the periodic table called alkali metals. They're very reactive. They'll react with the oxygen in the air, and they definitely react with water. The only way to test this reactivity is to drop it in water. When you do that, you change the chemical makeup. You have to define chemical properties by the chemical changes. So if we're talking about a chemical property, and I give you a list and say, tell me, is this chemical or physical? Think about whether or not the makeup of the substance, its atoms and its molecules, change when you are testing that property. So, comparison of physical and chemical properties. Take a few minutes and look at these three little boxes here and identify some of the differences between the physical properties and chemical properties of the three different substances here. The mercury by itself, this is an element made up of one type of atom. Oxygen, also an element made up of one type of atom. And then how it changes when all of a sudden those two elements combine, their atoms now combine to form molecules. Discuss that, think about that one a little bit and write a few things down in terms of your thoughts as to how this kind of sums up everything we're talking about here. Come into class on Monday ready to be able to identify whether something is a chemical or a physical change or a chemical or a physical property from a list based on the things that we have here.